Thank you for this warm welcome. And I believe we will be seeing my colleague in a minute here. Yes. Oleksii, hello. Anyway, my co-presenter today, my co-speaker is Oleksii Kaliuzhny. On the one hand, Oleksii is a student, and I helped him supervise his master thesis. We will be talking about that in a moment, and he's also a manager at Translatel. So, Oleksii, hello. Hello. Yes, we will. We're not trying to share our presentation. It's going to take a moment. And in the meantime, who of you has MTP experience? Okay, the majority. Who is happy about that experience? Okay, fewer hands raised. So today we will talk about this research that we carried out to assess the quality of machine translation. I can see that we have the presentation on the screen. Great, so next slide, please. All right. So we've already introduced ourselves. Now a little bit about our experience with machine translation. We've been doing this for a while, actually, the post-editing part, I mean, and the training and the surveys as well, this kind of research. Our first experience in the English-Ukrainian pair happened about 10 years ago. And for about 6 of them, I guess, we didn't say no to those projects just to keep up to speed with what is happening, to be able to see this language pair developing. Because the translation itself didn't really yield much. I mean, it was easier to translate from scratch than using the product, I mean, in the English-Ukrainian pair. And then about 4.5 years ago, we started receiving our first project where we could see some use, actually, of those machines in this particular pair. And at about the same time, we decided to do this on our own as well. I mean, take the academic approach. We started the research. So it was like bringing the effort together. I mean, of the academy that I represent, the university where I work, the translation department. That was on the one hand, and on the other hand, we wanted it to be interesting for the industry. I mean, hoping to solve some of the technical tasks at Translatel. So it was the academy and the industry brought together, the academia rather. Next slide. So, what are we going to talk about today? Today we will talk about automated quality assurance of machine translation, about the tools and the methods, and the effectiveness of the post-editing in our pair, I mean English-Ukrainian, then the systems that we are using, the topics in this language pair, etc. And of course, the most relatable part, perhaps, for the freelancers, which are the majority of the audience today, is what to do. What do we do to survive? The spoiler alert is you either adjust or find a niche, but about that we will talk in a little while. So, regarding the relevance, as I've said already, we started this a while ago, I mean the post-editing part. So why quality assurance? This is our experience. I mean, when we started receiving the first projects and we saw that the effectiveness or the performance was extremely poor, it was very difficult for us to explain to the client why the performance is so poor. I mean, why the translation completed by the machine is not usable. I mean, we tried to explain this in a formal way, and then we decided, or realized actually, that we should go for some international metrics. And even if the client doesn't understand what they are, essentially, it will still be effective in terms of explanation. So that would be our first step. If you want to somehow cooperate with your client, you need to be able to measure the quality somehow of the translation that you're getting. And if the quality is not sufficient, then somehow you need to adjust the payment. Because unless you do that, you should not go into machine translation in the first place. So that is why we chose this topic to discuss today. And now over to you, Oleksii. Oleksii will tell us a little bit about his master thesis. Oleksii? Yes, hello friends, colleagues. Today we will talk about machine translation. As you already know, we will also talk about how it impacts translator performance and about the experiment that we carried out at our company. When I was a student, I was very much curious about machine translation. Like probably most of us, I wanted to get it over, as soon as I can with my class and then go do something else. So when Oleksandr and I were exploring the topic of my research, we decided to bring together science and business activity. Hence the goal to explore potential performance of different machine translation systems in the English-Ukrainian pair to see whether and to what extent it can speed up the translation. So the goals were quite ambitious, and I guess at this point you'd like to know how we achieved them. First of all, we prepared a bilingual corpus, and funny as it may sound, we trained the system to actually translate. Then we translated a few pieces of text using that system, and then using the automated quality assurance systems that I will explain a little bit later, we measured the quality, and finally we engaged 5 experienced linguists to try and measure whether machine translation can help speed up the process of translation. So we broke it into very specific steps. And these are our guinea pigs, the ones that you can see on the slide. I mean, we reviewed dozens of publications on the topic, including the special aspects of applying these tools to certain language pairs. 2 of these systems that you see on the slide were trained on that bilingual corpus, and the other 3 we applied as is. And you will be surprised by the results, or might be, let me tell you that. So like I said, we broke the research into 2 parts. In the first part, we used automated tools, and then the second part was reviewed by an experienced linguist. We based the review on the most popular metrics that we applied to our translations, and I'm afraid those metrics are lacking. I mean, some systems are lacking those metrics, and in order to make this in order to bring it all together adequately, we had to do some of the work manually. The first system, as you can see on the slide, is BLEU. This system helps us compare the machine translation with a reference. So essentially, it just verifies the text. I mean, checks the number of words, whether they were translated in a certain order. Again, comparing it against its own options. This is what the metrics looked like, and of course the practitioners are improving it all the time, and it is actually more complicated than this. But since we are translators and not mathematicians, this was the first variation of the metric proposed. Like I said, because we had to do this part manually. Now, here is how it works. For quality assurance purposes, we took every sentence and applied this solution, as you can see on the slide. On top, there is the sentence proposed by the machine, and at the bottom is the reference. It's all really very simple. The arrows help us mark the words that match, and the mismatched words were just crossed out and left out of the calculation, I mean of the performance score. And then we use the form from the previous slide. Oleksii, let me just interrupt you for a second. If we could just take the video off the screen to make the slide larger, and then we will bring it back closer to the end. Thank you. Yes, now the results, the most interesting part. What did we learn from this automated assessment? We took 10 sentences, approximately the same complexity and length, ran it through all these through all the machines, through all the systems, compared with the reference that I just showed you on the previous slide, and got some average score that you can see on this slide. The first 4 systems, the neural systems, they are very much similar. I mean, there could be some variations, but for this metric, word order is completely irrelevant for the assessment of the performance. That is why this score is almost identical. The static results, I'm afraid, are rather sad, because the coincidence, the match, is only a quarter of what it could be, compared especially with the other systems. I mean, mid-sentence you could find a capitalized word. We still don't know why that happened, but that actually influenced performance to a great extent. Moving on, this was the second automated assessment system or quality assurance system, METEOR. Actually, you can say that this is the successor of the previous system that was improved. It is not simple. I mean, we do not just look at it on a word-by-word basis and not just look at the match. This is the formula, by the way. It looks a bit more complex than the previous one, plus every match also required an adjustment of this formula. The math was really very complicated, but we decided to put it like this for just for reference, for ease of reference. Now, this one you've already seen. not just your regular arrows, as you can see, but also the dotted lines. And unlike the previous system, this one assesses not just the exact match, but also the roots and the synonyms. Such as, for example, in this sentence that you can see, the word function is the exact match. You can find it in both sentences, but then defines can be translated with a synonym, sets, as you can see in the second sentence. So the previous system did not take that or this as a match, but this METEOR metrics believes that it's a partial match, or thinks that it's a partial match. These are the scores. The static system, once again, ranks last, but the performance is not as poor anymore. Regarding the neural systems, the gap is a bit bigger, as we can see between them. This is explained by the fact that METEOR takes into account the synonyms and the roots, which means that just one word can make a system a leader in this chart. Finally, the last system that we employed is the TER, or translation error rate, and it is more simple than the other ones. It looks at the options and the quality of those translation options or segments, requiring minimum post-editing effort. This is the formula. Once again, it is all very simple, and it is based actually on the same assumptions as the linguists use. I mean, the amount of effort that you invest for the translation to be of proper quality. No arrows, as you can see. Some words are underlined, some are crossed out. And those, by the way, are the words that need to be left out for the two sentences to fully match. And those that are underlined and in bold, they need to be added to ensure that the sentences match. So then we just looked at what to add and what to leave out. Then you insert them in the formula, and this is what you get. And also note that this metric is developing quite well. It's improving. The first variations would require, for example, that the word be replaced or moved. But this version has more similarity with the logic of a professional linguist. I mean, it is just one change instead of two. Again, the score and the static system ranks last once again. And for this metric, the best score is the lowest, which means that it requires fewer changes, and the higher the score, the more words you need to change. And so in the neural systems it was every second word, but for the static system it was roughly every word. Just for a more visual representation, here is a table, a consolidated table on this slide. So the greater number is the value that we got from this automated metric. And the number in the parenthesis is the ranking of the system. So, drawing some interim conclusion, we can say that neural systems produce more or less the same quality. One can rank higher for one metric and then lower for the other. It is we cannot identify the best one, not just yet, not at this point, but the worst one is obviously the static one, ranking the lowest throughout the research. And we believe, and we agree with this tendency, static systems are becoming obsolete. Now, the second part of the experiment was the post-editing. We, like I said, invited 5 experienced linguists, translators, and editors, and each of them had at least 2 years with Translatel on their record. So we translated a piece of 1,000 words using all those different systems. The topic was IT. And we asked every linguist to add their own option and to make it closer to the best result possible and measure the time. And we realized at that time that post-editing was widely used in other countries, but for our linguists it was rather new. So we had to start with a training for our linguists, just briefly to discuss the main criteria for post-editing. And as you can see, the most important ones are in bold on this slide. Effective use of the raw option of machine translation. Oleksii, sorry for interrupting. We have just 3 minutes left. Let's just move to the results. Okay. As you can see, our in-house model, we were surprised, by the way, ranks last. And you might ask, how come? And the answer is, again, really very simple. The standard models rely on a greater corpus because whatever you translate is used for the training of the engine. And in our case, it was just 4 million words. And so if we compare all those systems, Google Translate is the best, and Google just proves their leadership in the industry. And Amazon Translate, even though it ranks 3rd, we believe that this system has a great potential. Our experts believe that the challenge here might be that it either translates into Ukrainian through Russian or relies on something that was translated in that pair. At this, I guess, that would be all from me regarding the results. Back to you, Oleksandr. Yes, thank you, Oleksii. I just have a quick comment to wrap this up. If you decide to go for machine translation and post-edit, in this language pair, English-Ukrainian, you should not expect perfect quality. So when you negotiate with the client, use the metrics, as opposed to using your emotions, whether it is good or bad. I mean, if you combine all those metrics, that would give you the best results. But if you take the most simple one of them, the TER that Oleksii mentioned last, I mean, the number of corrections is divided by the number of words. This is the formula. And so the closer it is to 1, the worse the quality. So even such a simple formula can tell the the client that you know what machine translation is about, and it is easier to persuade the client that the quality is not as good than just saying that it's not good. Thank you. Yes, thank you. And I can see that we have a few questions from the audience. Do we have another mic? The one that is charged?
So
you don't really have really good metrics. Did it really happen that your custom model is even worse than the standard one? Was it due to the cleaning processes or the entry? Well, the subject matter that we opted for, we really had really good results in terms of training, even with Google. I'm talking about this particular chunk of text. Google had many more of them. That is exactly why their results in this particular area were to be expected when it comes to trained models, that they were really worse as compared to Google. You know, it's difficult to compete with Google at this stage yet. Yes, but I was really surprised the outputs. So we had the training process and testing. This is exactly how it worked. But then at the end of the day, it turned out to be a flop. Well, that was not really a flop. It could have been a flop if we had talked about industrial one. But here it was just learning experiment, and we really used it to work on our hypothesis. Yes, and maybe from left to right, there is a lady. She was, I guess, the first one. Yes. Thank you for the presentation. It was really interesting. This is a question about to add to what Konstantin has mentioned. So we talk about criteria for the text and the specialization. So am I right to understand that you had 5 people who translated, well, they post-edited the very same text, yes, and it had 1,000 words. No, I do apologize here. It was like one and the same big text. But then we took separate excerpts, fragments from that text. It wasn't really the same one because the people would get used to that, and it would be really easier for them to work on another one. So that was the same topic, but different fragments from the text. Oleksii, am I right? Yes. We had 5,000 words. We had several fragments. They were similar, but not exactly the same. And what about the area, the subject matter? IT, yes, of course. That was the same area. And yes, these were just different parts, but from the same text. Thank you, Oleksandr, for this very interesting presentation. From your experience, I think it's similar to what we've experienced. What do you do when the client has some discounts for machine translation, like 30% discount? Why is it not 35, 28 discount? And you understand that this estimate is not really adequate. So what is your reaction? How do you negotiate? What about the talks? What do you say? Or you just part with this person? It's a very interesting question. This is exactly why we wanted to have this experiment, to make sure that we can provide some reasoning that this kind of a discount is too big. And this is what I started with. We had some very long ladders, and you can still find the examples of these ladders. They were somewhere in our drawers, and we tried to explain that these are different languages. That is a flaxive language. That is a different one. We try to explain it to people that when it comes to the endings, it can work in a number of ways. But now we use the metrics and we show the results. And with these kind of results, we cannot really talk about 30% discount. Well, 10% is max, and this is only because we really respect you as a client. So when we use this kind of language, the language of math, the language of numbers, not the language of our emotions, it really impacts tags our client, it works much better than when you say it's a bad one. What about cleaning of TMS? Yes, we did that. It was really ideal when it comes to the application of the tags, because we used some high-quality texts which are better than the regular ones of our experiment. We already used... So you didn't clean? Yes, they were already clean. They were clean before that, and the quality was really high. That is why probably the result is a little bit higher as compared to the industry. If we took some, average experts, not really professional cleaning specialists. So Google really has very good corpora for IT, and I think that it's so difficult to compete with them when it comes to this particular field. Could you please pass the mic to Fyodor? The question that I have is as follows. In your understanding, what is the correlation between the results of the estimation of automated metrics and real efforts applied by a human with the discounts which one can offer to the client? Term metrics, just imagine we have a scope of some application. There you need to change only one word. Yes, and with term you will really receive a great result, but to clean it, to have this very minor correction, you will need to spend so much time, and the client will say, well, you just corrected one word, so probably 10%, this is what you can expect as your pay. And then another example, BLEU evaluation, well, METEOR stands out a little bit, so they mechanically compare two texts, with the exception of METEOR, because it really knows a little bit how to work with synonyms. So they showed the difference, not only when it comes to all the correct variants. So to my mind, they do not really reflect, they do not have this correlation between the human effort and the evaluation. What's your take on this? Thank you for this very relevant question, really to the point, and it's easy to see that you're a true professional. So what I can say is that, of course, no matter what is the matrix that we take, that is why we apply several of metrics and we try to have this optimal result. For a freelancer, for a person, well, an average freelancer, they will have to use this matrix TER. It's easy to remember, and the formula is really easy to grasp, to remember. But one of the arguments which really proves something is that when you need to correct one word, you need to read the entire sentence. But if you want to correct each word, you really need even more effort. So TER really works here. Well, probably it does not show everything. It's very objective, and no one can object this. But that is exactly why we use versatile metrics, and we use many of them, and that gives us this objective result. Of course, that you cannot really receive one result, and probably that's how it is.